All right, I think we're going to go ahead and get this rolling. Welcome. Thank you for coming. I appreciate it. The title of this talk is, Are You Ready to Fly the Enterprise? The hidden part is by yourself. This talk is on how operators run the Helm. Who am I? I'm Dave. I'm part of the Civo research team. I'm one of the research and development engineers there. I'm a photographer, and these are my eastern bluebirds, both the feisty little male and his wife. And my cat is named Kubelet because I'm that dork. I pick locks, again, because I'm that dork. And when we're done, you should ask me about my keyboards because I am that dork also. But Picard does not fly the ship. There may be one or two instances where you see him in the helm in the show, but he does not fly the ship. He has a crew of competent, well-trained staff, and they do most of the actions that he simply has to know that they are capable of doing. They support him in many areas, including weapons, engineering, navigation, defenses, and communications. Operators are crew in the same way that everybody else in Star Trek is. They offer a codification of the knowledge of the development team, so you can offer easy paths towards consistency, repeatability, reliability, and simplification. I will be using, for the examples here, the Percona operator for Postgres, to examine this in a little bit more detail. We all know that Picard had a crew member that was reliable, sometimes to a fault, Lieutenant Commander database. The Percona operator is a database specialist. And just like Picard, you do not have to know every fine detail of running a database on Kubernetes in order to run a database on Kubernetes. You can focus on what you need to do, not how you need to do it. Pre-planned actions become the method of operation, and the well-defined CRDs by the operator are a well-defined starting point, and leveraging Kubernetes gives you a lot of freebies, as we all know. So what can data do for us, though, is the question. First off, database creation. It's often considered a fairly important step in operating a database is making the database. It can involve a lot of pre-planning and hours of work, testing, and frustration in the end is something that comes up a lot. By using Percona's database operator to provision that database, you get a well-defined starting state along with repeatability of that deployment for quote-unquote free. An example of this is just how simple it is to actually deploy a Postgres database using the Percona operator. This is just cut right out of the Getting Started guide from the Percona website. There's not a lot of options there to get you something that is essentially a usable database with no fears of the future being a problem. The CR is a very powerful object in this conversation. Another benefit that you get out of the operator is backups. Taking a backup of an HA cluster is in many ways a very complex task, and it's not as simple as just MySQL dump to a disk. The Percona operator has proper backup methods that have been vetted and tested that are available for you to use. You get consistent backups from that operator because of the idempotency nature of operators and the immutability aspects of Golang. The same task generally results in the same results. And you have known restore paths. And scheduled backups, of course, with an operator are pretty easy if the operator has the ability to do cron format. This is just an example of Saturday night backup to S3, and we all know we love Saturday night backups. The next thing that Percona's database operators can offer, and generally any operators can do whatever they want, but they've given us replication here, and it's all the rage these days, as everybody knows. One database is generally not good enough for anything really. It's also very complex and easy to break replication. But by relying on Kubernetes, Percona has managed to give us a fairly straightforward way to actually implement replication using the kube control scale method. So I don't think there's really much of an easier way to put that into practice. See here. Sorry. Upgrades are another big offering that the operator can do for you. Upgrades are kind of a dangerous thing to do in my mind. They have to be planned carefully. You have to vet versions that you're going to be rolling to. You have to have a verified rollback method. And if you don't have those things in place, if something goes wrong, it's a quick scramble to try to unscrew your entire company in the end. By having a nice, consistent, codified way to do an upgrade, and Percona distributes their own Postgres distributions that are fairly well tested on upgrade paths, you don't have to worry about most of that. And you're hands off of that upgrade during the most dangerous aspects of it. An example of this is scheduled upgrades, which is something that needs to be done more often, but in Kubernetes especially, it's oftentimes scary to update our container images inside of our pods. And that is a lot of what this the upgrades functionality kind of keeps you away from, is getting stuck in that fear of not wanting to update because we're not sure if we'll break something. Safety is another big thing that operators in general offer. The operator itself is performing the actions on the cluster. It has CRDs that give you very limited option sets. And limitations are good. There's a million options for how to set up Postgres, and not all of them are, custom resource definitions. Yeah. The limitations can be an actual good thing for you. There's a million ways to configure Postgres in production, and not all of them are directly relevant to running them in production on Kubernetes. So you can strip away some of the options that might actually hurt somebody and be a foot gun later on in the end. And you get well-defined configurations because a CRD is a well-defined interface. And you can take some, at least, solace in the fact that you know that you're not putting extraneous options in. And anything that you don't configure in a custom resource generally has a sane, reliable default in place for that. Another way that operators can offer safety is in how they actually set up the pods for the Kubernetes infrastructure. In here, this is setting up a pod anti-affinity so that there is no two databases running on the same physical machine at the same time, which is, of course, a basic tenet of blast zone limitation. And by default, these are actually the anti-affinity rules that are applied in the Percona operator. So you kind of get that out of the box by using that. Yeah.
Only one pod should run in a node, so that means the environment node it's used by.
Not necessarily. Just in this case with databases, it's generally been considered bad practice to run two instances of a database engine on the same machine. And by using anti-affinity, you can spread those out, but there's nothing keeping you from running, say, HTTP daemons or proxy servers or anything else on that same node. It's just if you lose a node, you don't want to lose two replicas. And that's kind of I believe the reason why Percona put this in as a default is to keep you from getting into that mad, nasty situation later on down the road. Metrics are another big thing. In Kubernetes, we have often thousands of objects. At Civo, we have, I think about 90,000 CRDs per region right now. Or CRs, excuse me. The objects that those things are tied to, it's very difficult without a proper metric system set up to actually see the overarching story of what those metrics are trying to tell you. Sometimes we'll get stuck into positions where we are trying to figure out why one customer is suffering disk latency, and it turns out that it's disk latency for all VMs on nodes with a certain process running on it. And Percona does offer metrics. I believe they offer Prometheus metrics, but they have their PMM, I believe is the name of it. Yeah, the Percona metrics and monitoring that allows you to get some granular metrics on that individual database, which is kind of nice to have for free. You don't have to set that up with a complex multi-region, multi-tenant Prometheus setup like we have at Civo. And that's really the benefits that you get from just using any operators. You can do things like this, where you can limit and codify the understanding of a team into one specific section down into a CR. Essentially an operator is a knowledge base for operations and understanding around those operations and the pitfalls of them. Entire teams can have their knowledge dropped into code and given to people who don't have to understand the very specific nature of those actions, and they can move right on and use them still and leverage them in the same way that they were intended to. The only thing that you have to do is know how to ask the operator, which of course we do through YAML. That's about the end of the Percona bit. I do kind of want to talk about what we do at Civo with operators, a little bit ad hoc. But are there any questions on this content first? So Civo, we are a cloud-native cloud provider. And by that, we are a large set of installations of bare metal computers that have Kubernetes running on them. And when we provision customer objects, they are literally custom resources. So a CR is applied for a virtual machine. The main reason why we did this is it gives us a standardized interface to everything, both inside and outside the cluster. Our .com API side actually uses the custom resources in the Kube API to provision those resources on the clusters themselves, on the region clusters themselves. And all it has to do is put a watch out on that in Golang and wait for the status to be updated to complete. So when you go through and we can kind of show how the operators are doing all of this. I can't show you the operators themselves, but we can kind of go through an imaginary run through of what's happening with the operators at Civo inside the superclusters as I make a K3S cluster.
She's body.
So this is pretty standard cloud stuff. You've seen a cloud interface before, nothing fancy. And we're just going to set up a small cluster because we don't need anything serious for this. And I don't believe we need any applications, but we have a fairly large offering of those things in there as well. And I believe we even have...
So you have option to choose this term provided you like?
This is actually running on our cloud. Yeah, so this is going to be provisioned by the Civo region itself. What I'm doing when I'm filling this form out is I'm actually silently filling out a CR in YAML that the website is building and is going to be applying via a custom resource. This is going to be built in the London region. So when I click Create Cluster, the API is going to generate that custom resource object and make a Kube API request to the London supercluster's control plane. that is going to then get picked up by the Civo K3s operator. The Civo K3s operator will then look at that and say, in that spec, we need 3 nodes that are of standard size, and it's going to tell it the namespace that it needs to go to in the supercluster, and it's going to provision everything else. And how it's going to do that is it's going to ask other operators. So the first thing the K3s operator does is it lays down a specification for a network if there's not one already existing. When the network request is made, our network operator builds a layer 2 network in our data center using VXLAN and connects that into the places that it needs to go. The IP addresses are provisioned from an IPAM operator, and those are, again, in provision to CRs, and the K3s operator has asked the instance operator to build 3 instances. Once the IP addresses and the networks are built, the instances will get built by the instance operator, and it's cascading these status updates further and further back until we get to the point where the cluster is actually got virtual machines that have spun up, and those virtual machines are using KubeVirt. So those have been applied with a KubeVirt VM spec. And as they keep going and going and going through the reconciliation processes in all of our operators, and the status fields get filled, we'll see things like this node here has become ready, and the control plane is probably not ready yet, but we might be able to force a refresh and see it. And the also there's operators that provision routers, and the disk images themselves are provisioned by a disk image operator that pulls them down from an S3 bucket and caches them in memory on the host so we can provision quickly. Oops. Get kicked out of research, sorry. And in the time it took me to refresh that, it actually finished up building the cluster. So we do have, looks like 3 nodes on our control plane there. We can grab our kube config here, and we have the IP address. And every one of those things is represented in our supercluster as a CR. So the instances that are the nodes are defined as custom resources. That operator that consumes and processes and reconciles those provisions KubeVirt VM specs. Those then provision deployments and replica sets, and then finally the pod that has the QEMU container inside of it. The disk images are provisioned from our disk image operator, like I said, the actual OS disk images, and those are pulled from the host into the container through another operator called containerized data importer, which is part of the KubeVirt project. And essentially, once everything reconciles, the Civo K3s object that was applied by our API on the website has gotten a complete and ready status added to it, and then everything on the website reports from that. And the information on this website is actually pulled from that CR from the supercluster. So that's a little bit of how we use the operators ourselves.
And so this is
this is the 3-node Kubernetes cluster. Yes. We do have our database as a service, which we are doing in a fairly fun way. We're using the Percona operator in our superclusters. And when we provision the database, it gets provisioned in the tenant namespace. In our regions, the tenant namespace of the Kubernetes cluster is represented physically by a layer 2 VXLAN network. So when that database is provisioned, it's provisioned in the same LAN space. So you can communicate directly to it without having to go egress to the internet or even another part of the data center. It's going to be on that same local LAN. So you get some nice security considerations there as well. But you can access them externally as well from remote sources. But yeah, we can even launch a database. I've not had a chance to do this since we rolled this out. I've been building our machine learning platform, so I've been a little busy. But it looks like we have MySQL and Postgres, and we've been talking Postgres this whole time.
Like, how do you distinguish between the multiple person owners? Like, the same. So, did it by the namespace you distinguish, or there is something else? Like customary, and you don't want them to see that each other's data and
Yeah, they're in isolated networks. So the databases are not in the same network as each other. They're in the customer's database. And I don't actually have access to use it because I haven't updated my flags on the admin side of it to give myself DBAS access. So I can't show that to you, unfortunately. But yeah, the way that we do that, is the Percona operators. So we're using our tenant router actually to allow the Percona operator to talk out from the supercluster back into that VXLAN to do the health checks and every other one of the Percona operations that the operator needs to do without anything actually being in that customer namespace as far as the management side of it. That's all run by Civo.
And when you create a databases using the RB databases created on that one, again, once you have configured the Kubernetes.
I believe these are being created as Kubernetes pods, which are being backed at the bottom of it by NVMe over fiber over Ethernet through, that is Maya data, Maya store. So that's triple replicated on the actual block level physical devices on 3 nodes. So yeah. But the IaaS instances and Kubernetes nodes themselves are all actually VMs isolated with QEMU and KVM inside of KubeVirt. That's about the end of the little demo there. If I can find my mouse cursor again. There we are. Couple of things about Civo. We do have our Civo Academy, which is if you sign up, it's a free Kubernetes course. If there's anybody that you know who's trying to learn some stuff, we had some excellent people make those courses with us. Most of them are our employees. We have a Slack community, and we do try to foster community-driven development. We try to keep as many things as we can open in GitHub, like our marketplace. Anybody can make a PR to that. And our newest offering, of course, is Civo Databases powered by Percona. That is a fully managed DBAS offering. And if you sign up and you've never been a Civo customer before, you can get $250 to try out on that. And that is about that. So I greatly appreciate you coming. It is now my honor to tell you that was my first talk. So I hope I didn't mess that up too bad. I hope it didn't bore you terribly. And I hope you learned at least something about it. Thank you, guys. Now, are there any questions? Would you like to make fun of my hair? Anything of that nature? It's your time from now on, I believe.
So as far as the market, based on ratings are, is let's say they wanted to or the values data to see, well, we would just need to.
Yeah. You simply just open up a pull request. I believe it's Civo/marketplace on GitHub. We make things really easy because we name Civo -something for everything. But yeah, just submit it. We currently are going to have a new marketplace in the next few months, but we'll handle most of the migration on that. Currently, you just need to have a pretty simple deployment YAML or bash script or whatever. And we'll vet that, make sure that it's fine, and then put it out on the marketplace.
For What if it's cluster and it's dedicated?
It's a dedicated full-blown cluster. It exists in the Kubernetes namespace, in the supercluster, the actual physical cluster that we have. But it's provisioning KubeVirt virtual machines. So they're full KVM VMs. And they are in a layer 2 VXLAN network. So the namespace is the network logically and physically, and that's where they live. So by being in a namespace, if you spin up a pod in that namespace, it's going to exist in that actual IP space as well. So like our routers are actually just containers running a routing daemon that have the public IP address on them, but they exist in the same namespace and the same level, layer 2 layout on that VXLAN. So there's full isolation there at the layer 2 level through the switches. And a lot of that magic is done through Cumulus Linux and their just phenomenal switching gear, and Juno OS with their amazing ability to make BGP usable. Yeah, the entire core of our network is actually all eBGP, iBGP, and we're doing full announcements from each physical host for the IPs of the VMs on there. It actually was easier. You'll never hear that from anybody else, but BGP was easier. But yeah, any other questions? I think I'm a little bit early on wrapping up, probably about, yeah. Well, it was supposed to be a half-hour talk, and then they said it was 50. So I guess we can talk about operators, or you guys can, yeah.
Other constructs that usually are like operate and stuff, and so those sort of you have Civo at the both that.
Yeah, we have load balancers as well. Mm-hmm. Yeah, SSL, DNS, and you can see in the finding the mouse cursor is always the challenge, I swear. The cluster that we built just a minute ago, we can actually see that it was given a DNS address so that you can just automatically use it without having to mess around with a whole lot. But you can install either HA Proxy, Nginx, I think we have Envoy, Trafic, and a couple of others. And we had them all registered with our Cloud Control Manager into proper load balancers, so it can request a public IP address, and that gets stuck out in a pod through HA Proxy, and then the tunnel is complete at that point, and then it's just onto the layer 2 network. Yeah. And there's the DNS name, like I said. It's just a big ball of hex.
The minute is also in turn. That or the biggest failure domain within a region is.
The biggest failure domain within a region is the machine at the moment. Technically, the whole region could go offline if storage goes offline, which that's kind of the case with anything. But we're going to be migrating into a very heavily stacked system that limits the blast zone to many subregions that aren't exposed to the customer, and then there will be availability zones exposed to the customer as well. And currently you can just spin things up in 2 regions and call it pretty good. But yeah. You guys any more? All right. Well, thank you guys. I appreciate you. I'll let you go get some food and whatnot. Try to have a good day.